and we're going to do the next part, which is circuits. So Tinkercad allows you to also create virtual circuits that you can then create your own circuits with at home. So we're going to do a little bit of an overview of what this is all about. I'm going to click on Create New Circuit. Create New Circuit brings up a very familiar window. Notice I have that capability of rotation. I have a name that is a adjective in somebody's name. I have a circuit view. I can also do a component list. I have my next menu down, that rotation button, my ever-present delete or trash can, my undo and redo buttons. I can also annotate my circuit, and I can view hide sections of my circuit. So I'm just going to try a very basic circuit. I'm going to try an LED circuit. I'm going to make this a little bit larger, not quite that large. And I'm going to find a battery, so I'm just going to scroll down until I find the 3-volt battery. I'm going to pull that back. So that's like the coin batteries, the CR2032s that you have as a watch battery, something like that. Now that's a little bit too much voltage for most LEDs. So I'm also going to require a resistor. Now I'm going to take my resistor and I'm going to place it over here. Okay. Now I can make a circuit from this, and I'm going to draw wires. So you click on the end of one of these items, one of these circuit elements, and you drag down and it'll create a wire for you. You then can, when you have it a certain distance or straightness, you can click it and it'll make a little right turn for you, and then it'll connect to the negative element of your coin battery. I can then take the other end of my resistor and connect that to my LED. I can take the anode of my LED. I can just go straight here because you can see it very clearly. Click it on my coin battery, and now I have a complete circuit. The reason there's a resistor here is because the coin battery at 3 volts has too much power for an LED normally, and everything in here is accurate. Even though it's simulated, it's accurate. I've got my long leg of my LED attached to my positive, my short leg attached to my negative. I'm going to start my simulation and see what I see. And if I got everything connected correctly, my LED lights up. Look at that. So you can make it a bit more complicated, and that's what we're going to do now. I'm going to stop my simulation because I don't want to burn out my LED. I can take that wire I put up here. I can press the delete button and it goes away. I'm going to move my coin battery over. Notice that the connection I already had created between it and the resistor still exists. It doesn't move away because the wire just extends out, so as I move it around. So this time I'm going to put a switch in place. So the switch is going to be what initializes everything. So by putting a switch in here, I'm going to allow me to be able to turn on and off my circuit once I start my simulation. So the first thing I need to do is connect my anode to one part of my switch, to terminal 1. And then I need to carry the common or center to my battery. I'm going to click Start My Simulation. Actually, I'm going to move my switch position. Sorry, I'm going to start my simulation. Notice that my switch is on, but when I slide it over here, my switch is off, because I'm no longer making the connection between the common position and terminal 1. As soon as I move my switch to the other position, it's working. Gonna move off a little bit so we can see a bit better. So you can try this with a bunch of different components of a basic circuit. You can try a 9-volt battery, a 1.5-volt battery. You can incorporate Arduinos and DC motors. You can incorporate micro servos, gear motors. All sorts of things can be put into this circuit.